What if a magnitude 15 earthquake hit Earth? This isn't just a disaster. This is a planet-ending event. In 2011, Japan was hit by a magnitude 9.0 earthquake. That single quake shifted Earth's axis by 17 centimeters and actually shortened the length of that day by 1.8 microseconds. It was the closest thing humanity has ever witnessed to the absolute limit of what our planet can do. And that was only a 9. So what happens at a 15? Every ocean on Earth would vaporize within 0.1 seconds. Not flood, not tsunami, just gone. What about an 18? The entire planet gets blown apart, leaving nothing but a ring of rubble orbiting the sun. And a 25? The sun itself goes out. Today, we're going to do something a little wild. We're going to take the earthquake scale and stretch it from one end of the universe to the other. From the whisper of a single dust particle landing on your desk, all the way to the violence that can snuff out a star. And along the way, we'll figure out exactly where humanity fits on that scale. But before we go there, we need to clear up a misconception that almost everyone has. Most people think earthquake magnitude works like a thermometer. A magnitude 5 is 5. A magnitude 10 is 10. Twice the number, twice the shaking, right? Wrong. The moment magnitude scale is logarithmic. Every single step up releases not twice the energy, but 32 times more. Go up 2 steps, that's 1,000 times more energy. Go up 4 steps, over 1,000,000 times more. Let that sink in for a second. A magnitude 2 and a magnitude 6 earthquake differ in energy the same way a brick differs from a nuclear bomb. And a magnitude 15 is not just an upgraded version of a 9.5. It's more powerful by a factor of over 1 trillion. We'll get to 15 in a moment. But first, do you know the 3 most powerful earthquakes ever recorded in human history? Coming in at number 3, the 2011 Tohoku earthquake off Japan's Pacific coast, magnitude 9.0. The fault rupture stretched roughly 500 kilometers, like ripping open half the distance from New York to Chicago, all at once. The tsunami it triggered sent waves 40 meters high crashing ashore. That's a 13-story building completely swallowed by water. The quake also triggered the Fukushima nuclear disaster. Its effects are still being felt today. And yet, on the all-time leaderboard, it's only number 3. Number 2, the 1964 Alaska earthquake, magnitude 9.2. Most people today have never heard of this one, but it's the most powerful earthquake ever recorded on the North American continent. The fault rupture ran over 800 kilometers. Parts of Alaska permanently sank by more than 2 meters. In Anchorage, the ground split open, and entire neighborhoods slid into the sea. Tsunamis reached Hawaii. They even made it to the coast of Japan. And still, not number 1. Number 1, the 1960 Valdivia earthquake in Chile, magnitude 9.5. This is the single most energetic day in recorded human history. The fault rupture, 1,000 kilometers long, the equivalent of tearing the entire state of California in half. The resulting tsunami crossed the entire Pacific Ocean, and 15 hours later, still hit Japan with 6-meter waves. This is Earth's ceiling, magnitude 9.5. So why can't we go higher? The answer is surprisingly simple. Earth doesn't have a long enough fuse. Earthquakes get their energy from fault slipping. The longer the fault, the bigger the rupture area, the more energy gets released. To produce a magnitude 10 earthquake, you'd need a single continuous fault, 3,500 kilometers long, to rupture all at once. A magnitude 11? That fault would need to wrap nearly 1/4 of the way around Earth's equator. A magnitude 15? The fault length required would exceed Earth's entire circumference, several times over. The physics of plate tectonics simply cannot produce that. Earth cannot create a magnitude 15 earthquake on its own. But what if something didn't need a fault? Let's imagine an unexplained force, something we can't account for, detonating magnitude 15 worth of energy directly beneath Manhattan. At magnitude 10, every building in Manhattan over 20 stories collapses within 3 seconds of the first wave. Subway tunnels cave in. Underground pipes shatter across the city. At magnitude 12, the friction in the crust generates enough heat to partially melt the rock. The ground liquefies. Buildings don't fall over. They sink straight down into what used to be solid earth. If you were standing outside at that moment, you wouldn't see buildings topple. You'd watch the ground itself start to flow like water. At magnitude 15, this isn't an earthquake anymore. The energy release is approximately 10 to the power of 27 joules. The world's oceans aren't flooded. They're evaporated. The water vapor condenses into superheated steam clouds that blanket the entire planet within minutes. The shockwave punches through Earth's core and comes out the other side. The planet cracks from the inside out, like tempered glass being struck with a hammer. This is planetary-scale physical dismantlement. Humanity wouldn't even have time to be witnesses. But here's something even more counterintuitive. That magnitude 15 energy doesn't destroy the Earth evenly. It travels as a shockwave, bouncing back and forth through the planet's interior. Imagine striking a bell. The sound doesn't just disappear, it builds on itself. The first pass through the core is already enough to obliterate the surface. The second bounce tears apart whatever continental structure remains. By the third, the Earth's internal structure loses all stability. This isn't one explosion. It's a continuously amplifying resonance, a feedback loop of destruction. Magnitude 18. Energy reaches 10 to the power of 32 joules, equal to the gravitational binding energy of the entire Earth. That's the energy required to hold the planet together as a single object. A magnitude 18 earthquake would shatter the Earth completely. The solar system gains a brand new asteroid belt, made entirely of what used to be our home. But here's the thing. Once you cross 18, the energy stops being about breaking things. It starts rewriting the rules of existence itself. At this level, gravity becomes unstable. Matter no longer behaves in ways we recognize. You're not watching destruction anymore. You're watching the laws of physics themselves get pushed past their limits. Magnitude 24. This level of energy has only ever been observed in one place in the universe, a neutron starquake. Neutron stars are the ultra-dense cores left behind when massive stars die. Just 20 kilometers across, but with more mass than our sun. When their surface fractures in a starquake, the energy released in 0.2 seconds can exceed the sun's total output over 30 years. Magnitude 25. Enough to extinguish the sun. At this scale, life, civilization, and planets are nothing more than a rounding error in the universe's math. Now, let's pull the camera back. Does the magnitude scale have an upper limit? No. Does it have a lower limit? Also, no. Magnitude can be 0. It can be negative. It can go as low as you want. Here's what the other end of the scale looks like. Magnitude 1. A fully loaded cement truck falling from 10 meters up. Magnitude 0. Every player on an NFL roster running full speed, hitting a concrete wall at the exact same time. Magnitude -2. Your cat jumping off the dresser. Magnitude -5. The force of you tapping the screen right now to like this video. Magnitude -8. A single grain of sand falling onto a pile of sand. Magnitude -15. A speck of dust drifting through the air and silently landing on your desk. From that tiny whisper of a dust particle to the violence capable of killing a star. The two ends of this scale differ in energy by a factor of 10 to the 90th power. This isn't just a geology concept. This is the breadth of the universe itself. And human civilization? We exist in the narrow, fragile sliver between magnitude 0 and 9. We like to think of ourselves as masters of this planet. We like to believe the ground beneath us will always hold. But after looking at this scale, something becomes clear. Humanity's survival isn't a testament to our strength. It's a testament to our luck. We happen to live in the gentlest corner of a violent universe. Neutron star quakes have already shown us that magnitude 15 and beyond energy is real. It exists out there. It just hasn't happened here. Every second the ground stays quiet is the universe's most extravagant gift to us. Thanks for watching. This is What If Lab, where we look at the world from a different angle. If this scale left you feeling a little humbled, go ahead and hit like and subscribe. And tell me in the comments, how much longer do you think human civilization can survive in that tiny crack between 0 and 9? See you in the next one.